So this time, let's do the solving of linear equations using the substitution method. So we have here the two equations, negative 3x plus y equals 1, and then 4x plus y equals 8. So the very first thing we have to do here is, actually, you have to think right away that among these two equations, between these two equations, we should have one equation that we will what? We need to separate one variable. So what do I mean by that? Okay, let's say for example, we selected this first equation as our equation wherein we need to separate one variable. Okay, I'll just rewrite. So we have here negative 3x plus y equals 1. Again, either of the two equations you can select it. And then once you select one, what you have to do is you have to separate one variable. What do you mean by that is we can separate either x or y. And in this equation, I know for sure that the one easier to separate is actually the variable y. Because the moment we transpose negative 3x to the right side, what will happen? It will now become y equals the negative 3x will become positive 3x. And then, of course, we have plus 1. That's it. So, we're done on the first step, which is to separate one variable. Now, so what do we do on the other equation? Okay, actually, I call this one the main equation or somewhat the working equation. So let's use this one here. So we have again 4x plus y equals 8. Actually, we're trying to do this one, the substitution method, because we actually wanted here that we will just have one variable. And when we have only one variable, we can already solve it. So let's continue. 4x plus y equals 8. What I will do is I will just actually try to rewrite it. So 4x plus, now I am supposed to write y, right? However, I should take a look at here. Y is also the same or is equal to what? 3x plus 1. So in other words, they're just exactly the same thing. Y and then the 3x plus 1. So this time, instead of writing y, I will write here 3x plus 1. I put parentheses for safety purposes and then equals 8. Now, I'll just try to rewrite it again. So 4x plus, okay, since there's no number here to distribute, I'll just copy the one inside the parentheses. Now, what do we do next? We will just do the typical solving of linear equation. It's like we need to solve for x. How do we solve for x again? Make it solo, make it positive. So what do we do is, since both of these 4x and 3x are already on the left side, let's just combine them. So 4x plus 3x, that's gonna be 7x plus 1 equals 8. Now again, make the x solo and positive. So what do we do? Transpose the 1 to the right side. So now we have here 7x equals 8. What will happen to positive 1? It will become negative 1. So we have now 7x is equal to 7. Now, is x already solo? Not yet. So what do we do? Divide by 7, divide by 7. So x is equal to 1. But are we done already? Okay, not yet, because in solving systems of linear equation, what we need to do is we need to solve both for x and y. Okay, so now we have the value of x. Now, sir, what's the value of y? Okay, actually, what we can do is we can select either of the two equation, or actually we can use this one here. But let's say, for example, we just use either of these two. So let's say we use the 4x plus y equals 8. Again, either of the two, you will just have the same answer. So I will use the equation 4x plus y equals 8. What is the value of our x again? So value of x? 1, right? So now this time, instead of writing x here, I'll put here 1 and then plus y. We don't have yet the value of y. Then There you go. Now what do we do? Solve for y. What's 4 times 1? That is 4. And then plus y is equal to 8. How do you solve for y? Make it solo, make it positive. Is the y already solo? Not yet. So what do we do? Transpose the 4 to the right side. What will happen now? Y is equal to 8. What will happen to 4? Negative 4. So x 8 minus 4. So y is equal to 4. So we're done already. Again, we need to solve for the value of x and y. And then if you're asked what is the solution, your answer should be what? 1, comma, 4, x, comma, y, right? I hope this one is clear with you. You can actually try to go back again to the first part of the video if ever you still don't get it. But this time, let's have the next example. Okay, we will again use the same procedure. However, in this one, as you can see again, we need to find a way that we can separate one variable on either of the two equations using the substitution method. And actually, the second equation, as you can see, one variable is already separated. What's that variable? It's the variable y. So I will just use now the first equation as my main equation. So we have here 2x minus 3y equals negative 1. But to tell you, it's not always the y that should be separated. Actually, either x and y could be separated. So now what do we do? So I will just rewrite this. So 2x minus 3. Now, instead of writing y, what do I do? Remember, y is just equal to x minus 1 or the same thing with x minus 1. So I'll put here x minus 1 and then equals negative 1. Just copy it. Now what do we do next? We will just solve for x using our solving of linear equation. So 2x. Okay, now we have to apply distribution method here. What is negative 3 times x? That is negative 3x. What is negative 3? Again, what I did is negative 3 times x. And then now, what is negative 3 times negative 1? That's positive 3. And then, is equal to negative 1. Now, what is 2x minus 3x? Obviously, negative x. And then plus 3 equals negative 1. So what do we have now? Negative x plus 3 equals negative 1. But what's our goal again? To solve for x, right? By making it solo and positive. So what do we do? If I'm going to transpose the negative x to the right side, what will happen? It will become positive. So if I'm going to put the variable on the right side, I'm going to say, I have to put this one here to the left. So now what we have here? So 3, what will happen to negative 1? Positive 1 is equal to x. 3 plus 1 is 4 is equal to x. Or by using symmetric property, x is equal to 4. Okay. Now, are we done? Not yet. What do we do is we need to solve for y. Again, in solving for y, either of the two equation. Let's use, of course, the second one because I guess it's easier to use. So y equals x minus 1. What's the value of x again? What's the value of x? 4. I'll put here 4, then minus 1 here. So y equals 4 minus 1. What's 4 minus 1? That is 3. Okay, so our final answer should be what? 4, comma, 3. Okay, next example. This one here. So y equals negative 3x plus 5. And then 5x minus 4y equals negative 3. So what do we do here? Again, as you can see, the first equation, there's already one variable being separated. So let's take the advantage of using that one as our equation for the substitution. So I'll use the 5x minus 4y as my main equation. So I'll just write it. 5x minus 4y equals negative 3. Now, I'll just have to rewrite it. 5x minus 4. However, again, instead of putting y, what do I write? Negative 3x plus 5. This one, because again, y and negative 3x plus 5 are just the same thing. Okay? And then I'll just copy equals negative 3. Okay, next. What do we do? We have here 5x. Okay. What is negative 4 times negative 3x? Okay, negative times negative, obviously, that's gonna be positive, right? Now, what's 4 times 3x? That is 12x. Now, how about negative 4 times 5? That is obviously negative. And then 4 times 5 is 20, so negative 20. I'll just copy that equals negative 3. Okay? Next, what do we do? What is 5x plus 12x? That's gonna be 17x. And then, again, I just combine the two. Okay? 5x plus 12x. Then minus 20 equals negative 3. Again, our goal, make the x solo and positive. Is x here already solo and positive? Not yet. So what I do is I'll transpose the negative 20 to the right. So this will become now 17x is equal to 20 will become positive 20 and then minus 3. So 17x is equal to 17. So what do we do again? Divide both sides by 17 by 17. So x is equal to 1. Now, are we done already? Not yet, because we only have here the value of x. How do we solve again for the value of y? Again, you can use either of the two equations. But, okay, let's say we use the first equation. So y equals negative 3x plus 5. What is the value of our x again? There's a value already, right? That is 1. So I'll put here negative 3 times 1 and then plus 5. So y is equal to negative 3 times 1 is obviously negative 3 and then plus 5. So y is equal to 2. So our final answer should be 1 what? 1 comma 2. Okay? Let's have two more and then we will cut the recording already because I will have the part 2 of this. Okay. Number 4. So 7x minus 2y equals 21 and then 4x plus y equals 57. Again, what we need to do here is to think of which one will we use for, which one we will use wherein we can separate one variable. And I believe that the second one here, you see the 4x plus y equal to 57, it's easier to separate one variable here. I'll just write 4x plus y equals 57. Isn't it that the y here is so easy to separate, right? Because the moment I transpose 4x to the right side, what will happen? Y is equal to what? Negative 4x plus 57, right? That's it. Now, what do we do? So, I will use the other equation, the 7x minus 2y. So, 7x minus 2y equals to 21 as my main equation. So, now, what do we do? I'll just try to rewrite. So, 7x minus 2. Now, again, instead of writing the y, what do we do? What do I do? I'll put here negative 4x plus 57 and then equals 21. What do we have here? 7x. Okay. Again, we will do some distribution here. What is negative 2 times negative 4x? Obviously, negative times negative is positive. And 2 times 4x is 8x. And then negative 2 times positive 57, that's going to be negative. And then 2 times 57 is 114. And then is equal to 21. What do we do next? Okay, the 7x and 8x here are already together on the left side, so I can just combine them. So 7x plus 8x, that's gonna be 15x, and then minus 114 is equal to 21. Now, how do we solve again for x? make it solo, make it positive. So let's start by transposing the negative 114. So we have now 15x is equal to, negative 114 will become positive 114. And then we still have here 21, so plus 21. I hope you can still follow this one. So we have now 15x is equal to, what is 114 plus 21? That is 100. Where's my pen? Okay, 135. So what do we do? Divide both sides by 15 to cancel the 15, right? Okay, to further explain this one, let's use the long division. So we have 135, right? Divided by 15. So what's that number that we should put here? Actually, I guess it's gonna be 9 because 9 times 5 is 45. So 5 carry 4. 9 times 1 is 9 plus 4 is 13. 0. So x is gonna be 9. Now, are we done? Not yet, because we still have to solve for the value of y. Again, how do we solve for the value of y? We can select either of the two equations. So let's say we use the second equation. So let's say we use the 4x plus y equals 57. Again, what are we doing again? What we're doing is we're solving for the value of y. And then we already have the value of x. What is the value of x? That is 9. So I'll put here 4 times 9 and then plus y equals 57. Now, what's 4 times 9? That's gonna be 36 and then plus y is equals to 57. How do you solve for y? So what do you do? Transpose the 36 to the right side. What will happen? Y is equals to 57 minus 36. So y is gonna be what? 21. So our solution, the solution should be what? 9, comma 21. Okay, next one. Okay, now what if we have this one here? So 3y minus x equals 7 and then 2x plus 3y equals 4. Actually, my suggestion, actually, if you can observe it, the one I'm selecting for the substitution is the one with the variable that has a coefficient of 1. What do you mean by that? So, actually, a while ago, as you can see here, okay, number 1, right? I said, okay, this one, no, actually, there's already ones. Okay, this one here, we can select either of the two. So because here we have y and y. So because when we transpose either negative 3x or 4x to the other side, we will still have y on the left side. So how about this one is separated already? Separated. How about this one, number 4 here? For number 4, actually, again, if you can see this one, I selected the second equation, the 4x plus y, as the one to be transposed because if I'm going to transpose 4x on the right side, y is gonna be separated right away. As he said that. The same thing with this one. I'm going to select here the first equation, 3y minus x for the substitution because the moment I transpose, okay, let's say I will transpose negative x to the right side. So where did you transpose negative x? So that it will become positive. And then if I'm going to transpose 7 here, what's going to happen? Let's see what will happen. We will have now 3y. What will happen to 7? Minus 7 is equal to x. Do you see what happened? Can you check again? So negative x becomes positive. Positive 7 becomes negative. So now, sir, what's the purpose of that one? As you can see here, we already have a separate variable. But the separate variable is the x. X is already separated. So what do we do now? So I'm going to use the second equation as my main equation. So we have here 2x plus 3y equals 4. So I'll just have to rewrite this. So 2, now, is there already the value of x? Yes. The value of x in terms of y is 3y minus 7. And then plus 3y here. I just copy the 3y and then equals 4. Again, what I did here, I just replaced the x. So it's now 3y minus 7. Now what do we do here? So distribute. Distribute. Okay. So what is 2 times 3y? That's gonna be 6y. And then what is 2 times negative 7? That's gonna be negative 14. And then plus 3y is equal to what? 4. Okay, so what do we do again? Let's combine those with variable here. And then we have here 6y and 3y. They're both positive already. You can just keep them on the left side. So what is 6y plus 3y? It's gonna be 9y. And then minus 14 is equal to 4. How do we solve for y? What do we do is, again, make it solo and positive. So I will transpose the negative 14 to the right side. So it will become now 9y is equal to what? Positive 14 plus 4. So 9y is equal to 18. How do you solve for y? Divide by 9. Divide by 9. So y is equal to 2. Are we done already? Not yet. So what we can do is we still have to solve for the value of x. Okay. What's the value of x? We have here. Okay. Let's select either of the two equation. Maybe let's use the 3y minus x equals 7. What's the value of y again? The value of y is 2. So 3 times 2 minus x. There's no value of x yet. Equals 7. What's 3 times 2? It's gonna be 6. And then minus x is equal to 7. How do you solve for x now? How do we solve for x? Is x already solely and positive? Not yet. And actually, I can make x positive by transposing it to the right side. So what happened? Okay. By transposing x to the right side. So it will become now, when I transpose negative x to the right side, it will become positive x. And if I'm going to put those with variable to the right side, I have to put the 7 to the left side. Again, make it solo, right? So 6 will just retain. Now, what will happen to positive 7? It will become negative 7. But 6 minus 7, that's going to be negative 1, equals x. Using symmetric property, x equals negative 1. So our final answer should be what? Is it 2 comma negative 1? No, because again, it's going to be x comma y, right? So what's the value of x? Negative 1. What's the value of y? It's actually 2. Okay.